Hi and welcome to my tutorial. In today's tutorial I will show you how to hash data in C#. Before the tutorial I need to tell you a few things about hashing. So what is hashing, you might ask yourself? Well, hashing is, in cryptography, is creating a message digest. So hashing is actually creating a representation of a string with another string. Right, why is it so important, right? So what's the big deal with hashing? Well, hashing is very good for password protection and other means of authentication. Now, why? Well, you see, hashing is a one-way trip. Once the text is hashed, it's practically impossible to reverse the procedure. So once a password is hashed, no one will ever know what it is, unless he uses a quantum computer, but that's another level of programming. Okay, in this tutorial we will cover three algorithms: SHA-256, SHA-384 and SHA-512. Right, so begin with creating a form. My form is quite simple. It consists of two text boxes, a comment box, a status label and buttons. A text box 1 which holds the plain text, which will be then hashed, the hash box, text box 2 which will hold the hashed value, the combo box which will give a user the selection of hash algorithm, and a calculate and confirm button, right? So let's get to the programming. I think we're going to hold the hashing class in a separate file to make the code cleaner. So go to project, add new item, add class, hashing, let's call it. Okay, so I'm using system security cryptography, and in your namespace create public enum, call it supported hash algorithms. Yeah, it's fine. And in here it's SHA-256, SHA-384 and SHA-512. Those are the supported ones. And now in the class hashing, create a public static string compute hash, in which we will require string plain text, the supported HA hash, and we will also give the possibility of adding salt. Now some of you are asking yourself, what is this salt? Some of you already know that, and some of you probably just googled it. So what is this salt? Salt is a byte array that holds totally random non-zero bytes. It is of a random length, and its main purpose is to create the hash stronger. Now, why do we actually need to use salt, and why we should need to use salt? You see, there are many attacks to which it is possible to break through the hashing. Not revert it, but to guess the actual thing that was hashed, the actual word, sentence. Because most of people who are not really good or did never even hear of computer security do not know that setting up password to, I don't know, the name of your dog, which is I don't know even, or giving, I don't know, let's say you have a password, and normal person, what does with his password? Since he needs to remember it, so he either creates some very short, simple password that he can remember, or sets the thing that he will always remember. Say the name of his wife, or his birth date, yes. And such thing is so simple to crack that a good hacker takes about 20-30 minutes. So we don't want that to happen. That's why we use salt, random data that is hashed with the actual text or passwords, making it stronger. Actually, it makes it impossible, well, not impossible, but very unlikely that a hacker will crack the password or the hash with, say, rainbow table attack. Okay, so now going back to programming, we need to set the size limit, length limit of our salt. So int minimal salt length, I'll give four characters, and int maximum salt length is 16. 8 would suffice, but I prefer 16. Now create a byte array, salt bytes. This byte array will hold bytes, salt bytes, equals 0 at this point. We need to define it because otherwise it will give us errors, unassigned error actually. So if this parameter salt is not equal to null, so it isn't empty, it holds certain bytes, then those salt bytes are equal to salt. Since the probability is we're going to use the salt only when confirming the hash, right? So we have the hash, we extrapolated the salt from it, yes, and then we put it with the plain text and we hash it again. So okay, now the second option is that we set it to null and we want completely random salt bytes. So we create random r equals new random, and this random will give us the salt length. So int salt length equals that next of from min salt length to maximum salt length. So it will be within the borders of min salt length and maximum length, so between 4 and 6. So we have a salt length. Now we can define a salt byte. So salt bytes equals new byte array of the salt length. And now we have a salt bytes. We can fill them up with non-zero bytes. So RNG Crypto Service Provider will do that for us nicely. So RNG that get non-zero bytes into the salt bytes array and dispose of it. When it comes to security, if the class or the object is disposable and you have no need for it, you should dispose of it. It's more secure that way. So this is the salt actually. Now we need to convert the plain text into a byte array. So byte array plain data equals ASCII encoding UTF-8 to get bytes plain text. So I'm using the UTF-8 format because it holds Polish characters and all the other. If you use ASCII or any other formats, it's fine. It's up to you, but make sure you use the same formats in all the functions. Otherwise it won't work. So now we have plain data and salt bytes. We need those in one byte array. So byte array plain data and salt equals new byte array of plain data that length and salt bytes that length. Now we need to take all the bytes from plain data and put it into the plain data and sort. So int x equals 0, x smaller than plain data length, x plus plus. If you're wondering why I'm using the smaller here, it's actually because of how computer counts. You see, computer doesn't count from 1 and up, so 1, 2, 3, 4, 5, 6, 7. The computer counts from 0, 0, 1, 2, 3, 4, 5, 6, 7. Which means if the complete length of the plain data is 64, the index of the last byte in this array is 63. And that way the x will stay within the boundaries of its maximum index of the last byte in the array. If you would give smaller or equal, you would get out of boundary exception. So now plain data and sort, plain data and sort of x is equal to plain data of x. Yeah. Okay, now for the sort, for int n equals 0 and smaller than sort bytes, that length. This is the same story, right? The n needs to be smaller by 1 than length. Yes, it's from the index and how the computer counts. So then again, plain data and sort, and now the index of the byte is plain data that length plus n. So we pick up when we left in the for loop, and we continue here. So it's sort bytes now, sort bytes of n. Okay, so now we have plain data and sort in one array. We can now get to the hashing part. So switch hash, so the support hash algorithms, and case support hash algorithms SHA-256. Sorry, before the switch, create byte array hash value. I always forget about this one. Don't know why. Slips my mind. And now in SHA-256, create SHA-256 managed. SHA equals new SHA-256 managed. SHA. Right, now hash value equals SHA.compute hash of plain data and sorts, and then SHA dispose. Now you can just copy this entire case and paste it 2 times. We'll just change the type and the SHA from 256 to 384 in the second part. Also change the variable name, and in here it's SHA-512. Here also SHA-512, and here also SHA-512, and SHA. What the hell? F1. Right, so this is the hashing, and it's done. Now we need the sort bytes in order to confirm the identity of the hash, so to check it, if it's correct, if it really represents the text. If the sort bytes are different than the ones used in the original hash, then there is no way in the world that they will match, since it's about the hashing part, that there cannot be a hash of 2 different words that are actually equal. So say we have word h and n, and the hash of h cannot be equal to the hash of n. Never. That happens never. So now we will put the sort bytes on the end of another byte array, in which the hash value is the first value and then there is the byte value. So result. Byte array result equals new byte array with size of hash value. So the byte array that holds the hash, the actual hash. So hash value dot length plus sort bytes dot length. And again, we need to put all the data, all the bytes, all the data into it. So for int x equals 0, x smaller than hash value, dot length, x plus plus. And now result of x is equal to hash value of x. Now for the sort, int n equals 0 and smaller than sort bytes, dot length, and plus plus, and result of hash value that length plus n is equal to sort bytes of n. And now we have the hash value and sort in one array called result. Now we need to return the value as a string, so we're going to return convert to base 64 string result. You probably should use to base 64 string, it will work better. Actually, I even never tried using the encoding for that one. Nah, I probably will never try it. So public static ball confirm. We need string plain text, string hash value, and supported HA hash. Now we need to get the hash value as bytes, so byte array hash bytes equals, and now convert from base 64 string hash value. Now this is very important. Do not use ASCII encoding from UTF or anything else, because it will never work. Trust me, I tried it. Couldn't find the error for 10 or 15 minutes. Right, so that hash bytes. Now again, we need to know the actual size of the salt, one would think, because we need to get the salt from the hash, right? So we need the salt size, but we don't know the salt size because it's completely random. So we need to use something that is always constant, and that constant in our case is the single block size of the hash algorithm. Yes, I mean those numbers on the end of its name. Like SHA-256 means the block size is 256 bits equals 32 characters. 384 equals 48 characters, and 512 equals 64 characters. Simple mathematics. So now, before it we create int hash size equals 0, and then switch hash. We have three cases: the SHA-556, in which the hash size, as I said before, will be equal to 32 characters or 32 bytes, since one character is equal to 1 byte. Then again, 384 is equal to 48, and 512 is equal to 64. Now we have the hash bytes, the hash size. We can extrapolate the salt from the hash bytes. So create byte array salt bytes bytes equals new byte array, in which it will be the hash bytes dot length minus hash size. That way we will know the exact size of the salt, and we will be able to extrapolate those salts from the end of the hash bytes array. So for int x equals 0, x smaller than salt bytes dot length x plus plus, and then hash bytes, not hash bytes, salt bytes of x is equal to hash bytes of hash size plus x. Now we have the salt, we can get the final part of comparison of the two strings. So string new hash okay, so sorry for that. Now where was I? Right, the comparison. So string new hash equals compute hash of the plain text, the hash, which we have as a parameter here in our confirmable, and the salt bytes, which we extrapolated from the hash value. Now we need to return the value in which we will check if the hash value is equal to the new hash. Right? Now that's yeah, that's all. Looks pretty solid. And now to the form. God damn it! To the form. So let's start from the calculate button. You need to add using namespace of your project. In my case it's quick login. If you use different namespace, as in here is a different namespace and the form is a different namespace, you need to add this namespace, right? Okay, and now the button 2. So we need to use switch statement again, switch combo box 1.text, because we give the user the possibility of choosing his hash algorithm. So SHA-256, which is the first one, and now text box 2, the text is equal to hashing. We need to hashing, compute hash of the text box 1.text, supported hash, in this case is 256, and null, we want to generate a completely new hash. Now for the later ones, so SHA-384 and SHA-512, we simply change those. And that's for the compute hash. Now for the confirmation, so the checking, just remove the compute hash, copy the switch because we're interested in it. Not gonna write it. So right here, label free.text. In my case, it's the status label is equal to now hashing that confirm of text box 1.text, text box 2.text, and hash type of 256. Now, if true, then its text is equal to status that correct. If not, then it's equal to status incorrect. You can just copy it and paste it here, how that changes is simply the hash algorithm. In this case it's 384 and here it's 512. Right, that's all. Now let's check if it works. No apparent errors. Let's try to hash something. So password. We have a hash. So what appears to be a completely random text. Let's confirm it. Correct. See? Which means this hash, this message actually represents this text here. If we change the text and we do not calculate the new hash, we get the incorrect, because this hash does not represent this text. If we use password, then correct. Now the changes 384. Let's calculate anew. You can see it's longer, so confirm it's correct. Password, say this, confirm incorrect, and then again correct. And if you actually even cut it, close the application, open the application, paste it, and so all those confirm, then it's correct. You see it's always the same, there is no trick to it. And then SHA-512, calculate. This is way too long for databases. Confirm correct. Now change it, incorrect. As you can see, it works completely well. It works correct, and it's actually one of the best ways available to protect your password. So hashing, there are many algorithms, you can use those. However, please do not use SHA-1 or SHA or MD5, since those are susceptible to certain attacks. Like MD5 is susceptible to the collision attack, from what I can remember, since it's quite not very long. Anyways, that's all. So thanks for watching and see you later.